Welcome to EDU World Space.
Okay, so this is the free body diagram for the car. So now since both front and rear brakes are locked, therefore there should be two static friction on the car, which is the static friction at point A and the static friction at point B. So we know, let's assume that the car is in equilibrium. So we have the net force along the horizontal direction is equal to 0, which is equal to Fa plus Fb minus F cosine 30 degree is equal to 0. Fa here is the friction at point A, Fb here is the friction at point B, and F here is the towing force we're looking for to determine. So we know F cosine 30 degree can be equal to Fa plus Fb. Therefore, we have F is equal to Fa plus Fb over cosine 30 degree, which is equal to mu S times Na plus Nb over cosine 30 degree. Since we know the friction at point A can be equal to mu S Na, mu S is the coefficient of static friction, and Fb can be equal to mu S Nb. Okay, Na and B here are the normal force at point A and point B. Also, we know the net force along the y directions is also equal to 0. So we have Na plus Nb plus F sine 30 degree minus W is equal to 0. So we have F sine 30 degree is equal to W minus Na plus Nb. W here is the gravity of the car, in other words, the weight of the car. So now we can set up such equation here, which is the towing force can be also equal to W minus Na plus Nb over sine 30 degree. So now we have mu S Na plus Nb over cosine 30 degree is equal to W minus Na plus Nb over sine 30 degree, since both of them are equal to towing force. Therefore, this will give us Nb is equal to W cosine 30 degree over mu S sine 30 degree plus cosine 30 degree minus Na. So now let's take a look at the moments about A. Consider the counterclockwise moment is positive, therefore the clockwise moment should be negative, and this will give us such equation here. If we do some arrangement here, we'll have towing force can be equal to W times 1 meter minus Nb times 2.5 meter over cosine 30 degree times 0.3 meter minus sine 30 degree times 0.75 meter. So we know force F can be equal to mu S Na plus Nb over cosine 30 degree. Therefore, we have mu S Na plus Nb over cosine 30 degree is equal to W times 1 meter minus Nb times 2.5 meter over cosine 30 degree times 0.3 meter, and then minus sine 30 degree times 0.75 meter. So now remember, Nb can be equal to such equation here. So now we have Na plus Nb is equal to W cosine 30 degree over mu S sine 30 degree plus cosine 30 degree. So now we can use W cosine 30 degree over mu S sine 30 degree plus cosine 30 degree, substitute for Na plus Nb. So we have mu S times W cosine 30 degree over mu S sine 30 degree plus cosine 30 degree times cosine 30 degree. And this can be equal to W times 1 meter minus Nb times 2.5 meter over cosine 30 degree times 0.3 meter minus sine 30 degree times 0.75 meter. So now if we do some arrangement here, eventually you have Nb is equal to such equation here. So now we can determine Nb. Since we know the gravity can be equal to mass times the acceleration of gravity. So the mass of the car is given as 2,000 kilograms. In the question, it was saying that it's 2 megagrams, and 2 megagrams is equal to 2,000 kilograms, okay? And we know acceleration of gravity is 9.8 meter per second squared. If we do some calculation here, we'll have the gravity of the car is 19,600 Newton. And we know the coefficient of static friction is 0.3. So now we can plug in these values back into the equation. Eventually, we'll have the normal force at point B is equal to 81.07 Newton. So now we can determine the normal force at point A, which is equal to 85.99 Newton. So now we can determine the towing force, since the towing force can be equal to mu S Na plus Nb over cosine 30 degree. So now we can plug in the values for Na, Nb, and the coefficient of the static friction. Eventually, we have the towing force is equal to 57.87 Newton. And this is the answer for this question.